we've been learning different kinds of recommendation algorithms. We've already talked about content-based filtering and collaborative filtering. These help us find products which are of interest, are relevant to a user, given the user's ratings, their history, and so on. Now let's talk about association rules. These are slightly different. Association rules help us find products which are related to a product, but these are not exactly the same kinds of product. These are more the products that will be bought along with or used along with the products that we are looking at. Now, in business analytics and marketing, there is a very fancy task which is called market basket analysis. Association rules are very popular as a way to solve this problem, market basket analysis. Now, this is just a fancy term for trying to say which items are purchased together in the same transaction. So when a person walks into a store or goes to an online store, what kind of products do they put into the same cart? For example, do they buy cheese along with bread? The question could also be taken to mean that what kinds of products are bought by the same user within a short period of time. Now, this is actually a very useful thing to know. We've talked about this slightly in the past as well. We covered a little bit about association rule learning earlier, and we took an example there. Now, let's say you work at an e-commerce company as a category manager, and you're in charge of selling things like mobile accessories, cell phone cases, chargers, and so on. Now, your job is to sell a lot of this stuff and at a price that is as high as possible, but you can't spend too much on marketing. So, what if you could figure out somehow that the folks who bought adapters and earplugs were also likely to buy cell phone chargers? For your job, this actually turns out to be really useful information, because then you could bundle adapters, maybe give an offer, show recommendations to a user who has purchased adapters and earmuffs. Bunch of different things that you could do if you knew that this rule existed. And finding out rules of this sort is exactly what association rule learning is all about. So we've seen how association rule learning can be useful, but how do we actually do it? This is where the Apriori algorithm comes in. This is actually the most well-known technique for mining association rules from transactional data. And in fact, the paper that proposed this algorithm is so popular that it has been cited about 19,000 times. The Apriori algorithm is a data mining technique that helps us mine basket data or data about transactions for association rules. Now here a basket has two different meanings. One could be a single transaction. So a basket represents all items that were bought in one single transaction. Or it could be items bought by user over a short period of time, say a month or 2 months or so. Now let's say we have a bunch of basket data that looks like this. Basket 1, which contains a bunch of products like bread, milk, butter, radishes, and so on. Basket 2 has only bread. Basket 3 has juice, chicken, and corn. Basket 4 has a different set of products, bread, butter, and tomatoes. Basket 5 has a different set of products, bread, milk, butter, and pumpkin. You feed this to the Apriori algorithm and you will come out with some association rules. These rules will tell you what kind of products are purchased in the same basket. One rule could be that the addition of bread to your cart increases the probability that you will also purchase butter in that same cart. This could be one rule that the Apriori algorithm comes up with. The other rule could be that bread and butter, once they are added into a cart, increase the likelihood that you will also purchase milk. So the a priori algorithm takes in the basket data, which looks like the data on the left, and comes up with rules that look like what you have on the right. These rules are not just any old rules, they have to satisfy certain conditions. Each rule has to have a minimum support and a minimum confidence. Support and confidence are metrics that are defined in a way that tell us how valid a rule is and how strong the association is. Support tells us how many out of all the transactions contain the items in the rule. Confidence tells us how many of the transactions out of all the transactions which contain those items exhibit this association. Let's start with rule 1. Let's compute the support and confidence. The support of the item bread, which is on the left side of rule 1, is the proportion of all transactions that contain the item bread. So we have 5 baskets here, out of which 4 contain bread, so the support of bread is 80%. Similarly, we have the support of butter. This is out of all the transactions, how many contain butter. Out of all the transactions here, 3 of them contain butter, so the support for bread is 3/5, that is 60%. Support is a metric that specifies the minimum number of samples required for a rule to be statistically significant. Let's say an item has been sold too few times and you find a rule that contains that item. There isn't really enough data to support that rule. It may or may not be valid. So the support helps us actually say whether that rule has enough data to support it or not. The support is defined as the proportion of baskets which contain the items on one side of the rule. And each rule has to satisfy the minimum support. Both of the sets on either side of the rule have to have a minimum support for that rule to be a valid association rule. Now let's talk about confidence. Confidence is a metric that tells us how strong the association actually is between these two sets of products. We have one set of the products on the left side of the rule and one set on the right side of the rule, and confidence tells us how strong this association is. Let's see what the confidence of the association between bread and butter is. For that, you would compute how many times bread and butter were bought together instead of separately. And if they are bought together more often than separately, then there is a strong association between those two products. So to compute that, you would take the support of the set bread and butter. This is the proportion of all the transactions which contain both bread and butter, which is 3/5, and divide it by the support of bread. This is the proportion of transactions which contain only bread. So you are saying out of all the transactions which contain bread, how many transactions also contain butter? In this case, it turns out to be 75%. The a priori algorithm only accepts rules which satisfy a minimum level of confidence. So unless the rule satisfies both these constraints, it has a certain support and a confidence, it will not be considered a valid rule. The confidence can be formally said as the proportion of baskets which contain items on both sides of the rule as compared to the left side alone. Now let's say the goal was to find all possible rules that satisfied these two conditions. They had a minimum support as well as a minimum confidence. The a priori algorithm actually does this in a very efficient way. It will start by generating 2 item sets, then 3 item sets, and so on. It will find the 2 item rules first and 3 item rules next, and so on. At each step, it will also drop the items which don't have enough support. By doing that, it will reduce the number of items we need to look through to find rules. Let's take this set of baskets that we have here and work through the a priori algorithm step by step. The first step is to find all possible single item sets. This would simply be one set for each product that has ever been sold in any transaction. So start by finding all the single item sets. In this case, we have all this set of products which were in any of the baskets that were sold. Then you would filter for only those item sets which have a minimum support. Let's take a number for minimum support here. Let's say it's 2/5. So you need to filter for the item sets from the above set which have at least 2 of the baskets containing that product. So out of all the sets in the first step, only 4 of them have a support of 2/5. That is, they were purchased in 2 out of the 5 baskets. Next, find all the 2 item sets that you can generate from this set of 4 items. This is the set from which we'll start generating rules. But first we need to filter only for those item sets which have a minimum support. So look for the pairs of products which were sold at least twice. So look for pairs of products which were present in at least 2 out of the 5 baskets. This leaves you with 3 pairs: bread and milk, bread and butter, milk and butter, which were present in 2 out of the 5 baskets. All the other pairs were sold only once or never at all. Step 5 is to find the rules which are possible from this set now. So we have 3 pairs, which means that there are 6 possible rules. We'll find the confidence for each of these rules and filter only for those rules which have a minimum confidence. As you remember, the confidence is the number of transactions which contain both of the products divided by the number of transactions which contain the product on the left side. This is equivalent to saying take the support of both the products in the rule and divide it by the support of the product on the left side of the rule. So let's take the rule on the top left, the bread leading to a purchase of milk. There are 5 baskets overall, out of which 2 of them contain both bread and milk, and 4 of them contain bread. So the number that we are looking for is 2/5 divided by 4/5, which will be 50%. This is lower than 75%, so we need to drop this rule. Similarly, if you look at the rule bread leading to butter, it has a confidence of only 50%, so we will drop that rule as well. So at the end of step 6, we are left with 4 out of the 6 rules that we generated in step 5. Now these rules all have a confidence which is above the minimum confidence, 75%. They all also have a support which is higher than the minimum support. So we will accept these rules and move on. We will add these rules to a list of learned rules, and these are all the 2 item rules that are possible from this set of baskets. Next we can go on to find the 3 item rules. For that we'll find all the 3 item steps from the items which were remaining in step 4. We've already dropped a lot of items because the pairs didn't have enough support and so on. Now we have to see if we can generate 3 item sets and if any of those 3 item sets has enough support and enough confidence to give us a new association rule. Now, since there were only 3 distinct products that were left in the earlier step, we can actually generate only one 3 item set, and that set was actually sold in 2 out of the 5 transactions, so the minimum support is satisfied. So we'll keep it and find all the possible rules from that set. So these rules will be such that there will be two products on one side of the rule and one on the other side of the rule. So the purchase of two products which lead to an increased likelihood of a purchase of a third product. And we have three such rules possible here. The next step is to find out which of these have a sufficient confidence to be added as an association rule. All of these already have the sufficient support. To find the confidence, what you need to do is take all the transactions which contained both the items on the left side of the rule and see out of those how many transactions also contain the item on the right side of the rule. And if that proportion is greater than 75%, this association is strong enough to be added as an association rule. If you look at the middle rule here, bread and butter leading to milk, bread and butter were purchased together in 3 out of the 5 transactions. Only 2 of them contained milk as well. So 66% is the confidence of that rule, which is lower than our minimum confidence of 75. Hence, we drop that rule. This leaves us with 2 more rules that we can now add to our association rule set. So now, on the whole, we have learned 6 association rules. The a priori algorithm will keep going as long as it can find rules which have the sufficient support and confidence. In this case, we cannot make a 4-item set which has a sufficient confidence because we were left only with 3 items in the last step. So we stop here. But as long as you can continue making sets which have a sufficient support and then generate rules which might have the required amount of confidence, you can continue along the same lines for the a priori algorithm. So we've seen how we go from a set of basket data to a set of association rules using the a priori algorithm. The a priori algorithm is very efficient at finding these rules, but one challenge is that there are too few item sets sometimes which satisfy the minimum support. So in fact, you will see that many times you will not even get to the 3-item sets because you don't have enough items with support. Now this might lead to missing out on some strong associations because we don't have enough data to satisfy the support condition of the a priori algorithm. And when the data has this quality, it is difficult to use association rules a priori algorithm to find the associations. We've talked about a bunch of different ways to find recommendations. We'll actually implement a few algorithms in Python in the next few lectures.